Lesson 30-1, Translations of the Quadratic Parent Function. Learning targets, graph translations of the quadratic parent function, identify and distinguish among transformations. All right, the function y equals x squared, or f of x is equal to x squared, is the quadratic parent function. Okay, complete the table for y equals x squared and then graph the function. Of course, we're just squaring the input value and that's all we're doing here. So we'll go ahead and do that. So -3 squared, of course, is -3 times -3, which is 9. -2 squared, of course, is 4. And -1 squared, of course, is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. And 3 times 3 is, of course, 9. So that's how we have that. All right, then, of course, it's asking you to graph this, and we'll take a look at the graph on here. And if you notice, let's look for some of these points. We have, of course, we have our -3, our -3, and 9. So it's our -3 and 9 is way up here. And then, of course, our -2 and 4 is right there. And, of course, our -1, 1 is right there. And then our 0. And then our +1 squared is 1. +2 squared is 4. And +3 squared is 9. So you can see those are the points that make up this graph. Number 2, use words such as vertex, maximum, minimum, increasing, decreasing to describe the graph in y is equal to x squared. And of course, in this circumstance, we're trying to use some of the vocabulary that we've used in our functions unit as well as throughout the course. And if we notice what's happening here is as we're moving from left to right, the graph, of course, starts off to where it is decreasing until it gets to a minimum value. And then after that, it begins to increase and continues to increase forever. There's a definite change, and of course, the change in direction when it changes from increasing to decreasing, or from decreasing to increasing, I should say, is going to be the vertex. And that's that point where it changes direction. The line passes through the vertex of a parabola and divides the parabola into 2 symmetrical parts, and that would be called the axis of symmetry. So if we go back and take a look at this graph right here, the axis of symmetry, of course, would be this line right here. And not because it's the x-axis or anything, but because that's the vertical line that goes through the vertex. That's the vertical line. That's the vertical line that goes through, I'll do it this way, the vertex. Okay? That's what your axis of symmetry. This is also called, or commonly called, the line of symmetry as well. Axis of symmetry or line of symmetry. All right, and of course, we want to write the equation for the axis of symmetry. Well, the equation, of course, it's a vertical line. It's a vertical line, and so therefore the vertical line is always going to be x equals some value. So in this case, it's going to be x is equal to 0, because it happens to be the y-axis is what it happens to be. And the y-axis is all the y values are infinite, but the x value is always 0. X value is always 0. All right, so let's go ahead and take a look at item number 4. It says complete the second and third columns of the table below. Leave the fourth column blank for now. And so we're going to go ahead and figure this out. So we have x is equal to, and these numbers are the same numbers that we had a moment ago. -3 squared, of course, is positive 9, negative 2 squared is positive 4, positive 1, 0, 1, 2, 1, 4, and 9. Okay, 1, 4, and 9. All right, so remember in the previous lesson we did first differences and second differences. First differences where we're checking to see whether it's linear without looking at the graph. And we know, we looked at this graph, we know it's not linear, but let's just go ahead and go through the process. The first difference is going to be the difference between these numbers here. And so that, of course, is going to be a negative 5. Because remember, it's the 4, it's the second number minus the first, so it's going to be 4 minus 9 is equal to negative 5. And then we have our 1 minus 4, which is negative 3, or 0 minus 1, which is negative 1, and our 1 minus 0, which is 1, our 4 minus 1, which is 3, and our 9 minus 4, which is, of course, 5. Okay, so we can tell by that that this is not linear. All right, so now, after that, item number 5, it says, I'm going to read off the book because I don't want to scroll off the table. It says the fourth column in the table is titled Second Differences. Complete the fourth column by finding the change in consecutive values in the third column. What do you notice about these values? So when we do our second differences, again, we're not going to have anything there, and we're not going to have anything there, but we have our minus 3 minus a negative 5. So it's negative 3 minus a negative 5. And of course, we know when we have our double signs, we change it to a plus. So it's negative 3 plus 5, which is a positive 2. And we have the same thing here. We have our negative 1 minus a negative 1. All right. I'm sorry, minus a negative 3. And so that's going to be a plus. So it's negative 1 plus 3. And that's going to be equal to 2. Minus a positive 1 minus a negative 1. And of course, that's a plus. It becomes 1 plus 1, which is 2. And then 3 minus 1 is 2. 5 minus 3 is 2. So you notice that the second differences are here. What this is telling you, the second difference is telling you that your problem is a second degree problem, or it's going to have an x squared in there. It's going to have an x squared in the equation. Item number 6. Complete the table for f of x is equal to x squared and g of x is equal to x squared plus 3, and then graph the functions on the same coordinate grid. All right, so again, this one here is going to be the same as what we've already had. So that's going to be your 9, 4, 1, 0, 1, 4, 9. And we want to look at this. Now, I need you to recall when we did translations before, when we did translations. And remember that since the original function is x squared, we're still doing that original function. We're still doing x squared. Then we're adding 3. In other words, we're adding 3 to the output. We're adding 3 to the output. Okay, so this is going to be a translation that's changing our y value. And remember, our y value is up and down, up and down. Okay, in other words, we're just changing our y value by taking our output that we had before and adding 3 to it. Obviously, that's going to raise it up. And we can just take a look to verify on here. If we do this, we have our 9 plus 3 is 12. Our 4 plus 3 is 7. Our 1 plus 3 is 4. Our 0 plus 3 is 3. Our 1 plus 3 is 4. 4 plus 3 is 7. And 9 plus 3 is 12. And we can see that all of these numbers, all of these y values for the same x is up by 3 higher. Okay. And of course, the graph confirms that as well. When we take a look at the graph on here, we can see that the graph is the same, it's just everything's raised up 1, 2, 3. And we can look at the points everywhere. Here at 1, it was here, and now it's up 1, 2, 3. Okay, it's up 1, 2, 3. Same thing with at the 3. Well, let's see, you can't see it here. At the 2, you can. We're at 4, now we're at 1, 2, 3, and 7. Okay, so you can see that what's happening here is the graph is raised up up 3. All right, so as we continue on, take a look at what's going on here. It's asking us to identify certain parts here. So the vertex of the parent function was at what point? Well, the point was, right here. The point is right here. I'm pointing to it. There you go, right there. And that, of course, is the point 0, 0. And it's the minimum value, the lowest point. Now the domain. The domain is interesting. When we take a look at this graph, what you'll notice is that it's slanted upward. So that means it's going to have a component that is going that way and a component going that way. In other words, in the x direction, it's going to go forever that way. And same thing here, goes up a little bit and then that way. So the x direction is going to be forever that way. And since there's no gaps right here, that means our domain is going to be all real values of x. All real values of x. Okay, so, and then the range, think about the range. Ranges are y value. And this is a graph where all the answers are going upward, it's starting at 0. So our range, of course, is going to be all real values of x where x is greater than or equal to 0. And of course, the axis of symmetry is going to be what we said it was before, x equals 0. X is equal to 0, okay? Because the vertex is going through the origin 0, 0, or it has an x value of 0, the solution is going to be x is equal to 0. Now, this next one here, we're going to be using this x minus 4, which is the graph that's right there above. So what changes? Well, the vertex went down by 4. Down is my y value, and it's this number right here. So that's going to be 0, negative 4. Okay. And then the domain, is domain going to change? No, it's not. It's still going to be all real values of x. And my range, is my range going to change? Yeah, instead of going through the origin and up, it's going, your minimum value is now negative 4. So x is going to be greater than or equal to negative 4. Okay. And of course, the axis of symmetry, so that didn't change. It's still, when you look at the vertex still has an x value of 0, and it's a vertical line. So it's going to be x is equal to 0 still. Number 8 says compare the functions of g of x and h of x in items 6 and 7 to the parent function f of x is equal to x squared. Describe any patterns you notice. Okay, so on the equations, what we noticed is that the change came after the input value being squared. In other words, g of x, for example, was equal to x squared, which was the parent function, plus 3. So that was the parent function. That was f of x. So we could have written this as g of x was equal to f of x plus 3. Because essentially that's what happened. We took f of x, and then once we calculated it, then we just added 3 to it. Okay, and that's what happened in both cases. The tables, what we noticed on the tables is that all of the y values for g of x were 3 more than the y values of f of x, and all the y values for h of x were 4 less than all the y values of f of x. We noticed the graphs were all parabolas that looked about the same. The only difference was the translation. G of x was translated up 3. F of x was translated down 4. D, the vertices, or the vertex. The vertex moved in the same way as the other translation. So for g of x, the vertex moved up 3, and for h of x, the vertex moved down 4. We noticed that the domain for all of these were all real values of x. And I got to tell you, you're going to find that in for most parabolas, I'm going to say most, it's probably all, but I'm going to say most parabolas are going to have a domain of all real values of x, unless the real world situation tells it differently. Like, for example, if you have a situation that doesn't make sense to be negative, well, then your input values would not necessarily include the negative values. But if we're just talking about equations and parabolas, your x is going to be all real values. Your range values are going to be whatever the y value of the vertex is, and because these are both opening upward, I like to call them happy flowers, they're opening upward, then they're going to be all real values of x, of y, greater than whatever the y value is of the vertex. Whatever the y value is of the vertex. I think earlier I said x value for the range. I apologize, it should have been y. The axis of symmetry, in this case, in all three equations, the axis of symmetry was the same. It was the x-axis. And again, the reason for that is there was nothing that we did to make it move left to right. So the changes to the parent function in items 6 and 7 are examples of vertical translations. Okay, they're vertical translations in that they moved vertically, they moved up and down. A translation of a graph is a change that shifts the graphs horizontally, vertically, or both. A translation does not change the shape of the graph. Okay, so the graph looked the same. Only difference is that in this case, it was its position was moved vertically. Item number 9 makes sense or make use of structure. How does the value k in the equation g of x is equal to x squared minus k change the graph of the parent function? Okay, and in this case it says, because it's a minus sign, it's going to move the graph down. So the minus sign is telling you it's moving it down k units. It's moving it down k units. All right, so the rest of the lesson, or the next part of the lesson, is check your understanding. And I'm going to skip that. I'm going to let you guys do that on your own. We will move on to the next part of the lesson. So don't forget to go back and check your understanding and make sure you understand what's going on here. Let's go down to item number 13. Okay, item number 13. Item number 13 is, it says complete the table for f of x is equal to x squared, and k of x is equal to x plus 3 squared. Again, this is another translation, so I just want you to recall from when we learned about translations, is the changes happening to the x before the function is run. The function is we're squaring the input value. Here, the input value is changed. All right, so item number 13. Complete the values for f of x is equal to x squared and k of x is equal to x plus 3 squared, and graph both functions on the same coordinate grid. So we'll go ahead and fill this in, and these are the same numbers that we had before. They're the 9, all right, the 4, the 1, the 0, the 1, 4, and 9. So now k of x is we're changing our input value, so we're adding 3. So if I put in x is negative 3, before we square it, it's negative 3 plus 3. So negative 3 plus 3 is what? Well, it's 0, and 0 squared is 0. Negative 2 plus 3 is going to be 1. 1 squared is 1. Negative 1 plus 3 is positive 2. Positive 2 squared is 4. 0 plus 3 is 3. 3 squared is 9. 1 plus 3 is 4. 4 squared is 16. 2 plus 3 is 5. 5 squared is 25. And 3 plus 3 is 6. 6 squared is, of course, 36. Now, if you look what's happening is it turns out our x value is actually going to change, and the way we can see it on the graph is we're looking at, okay, -3 was at 0, and on the second graph, but the output was 0 at 0 before. So in other words, for the output to be 0, I changed from 0 to -3. On the graph, is that moving left or right? Well, obviously, as I'm going in this direction, that's left, and going in this direction, that's right. Okay, as I'm decreasing my values of x, I'm going to the left, and as I increase my values of x, I'm going to the right. So we look at, okay, 0 was on both of these, okay? And on the first graph, 0 was, the output being 0 was where x was equal to 0. And that same location, that output being 0, was now where x is equal to -3. So you can see you've moved to the left 3. Now let's check the graph and see whether the graph agrees with me on that. And sure enough, the graph does. I'm going to, okay, so you can see here that if we're looking at the x is equal to 0, the x-intercept, if you would, it is now moved over here. It is moved a little bit, and it is moved to the left 3 units. It is moved to the left 3 units. So again, just like the translations unit we did before, if we're changing the input value by a positive value, it changes it to the left. By a negative value, then it would change to the right. Okay, and we're going to confirm that in just a moment. All right, so let's go ahead and identify the what happened here. The vertex on the parent function, of course, was 0, 0. But the vertex on the k of x was not 0, 0. It was still at 0, but it was at -3. -3, 0 was the vertex. Okay. The domain, again, both of them are going upward, and they're spreading out. So again, as I said before, it's probably going to be all real values of x, and it is for both of them. Okay. But the range, let's see, does the range change? Well, the range doesn't change either, because we didn't move up or down. These are still going to be, y has got to be greater than or equal to 0. Y is greater than or equal to 0. Because the vertex is on the x-axis. And the axis of symmetry, remember, the axis of symmetry is a vertical line that goes through the vertex. In other words, it's going to be a vertical line wherever your x value is. Because remember, vertical lines are x equals. So here it's going to be x is equal to 0 for f of x, because the x value of the vertex is 0. And here it's going to be x is equal to -3, because the x value is -3. So your axis of symmetry is going to be a vertical line going through the vertex, and the equation is going to be the x value of that vertex. Item 14, complete the table for f of x is equal to x squared, and p of x is equal to x minus 4 squared. And again, remember, we're making the change to the value that's being squared. So therefore, it's going to be a translation that's going to be left or right. And it should be in the, since it's a negative value, it should be to the right, okay, based on what we learned before on translations. All right, so let's just see if it works out. So we have x squared or x value. So -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So let's go ahead and do the -4. So we have -1 minus 4, which is -5. -5 squared is 25. 0 minus 4 is going to be -4. -4 squared is 16. 1 minus 4 is -3. -3 squared is 9. 2 minus 4 is -2. -2 squared is of course 4. And then 3 minus 1 is -1. -1 squared is 1. All right, and then 4 minus 4 is 0. 0 squared is 0. And of course, 5 minus 4 is +1, which is 1. All right, again, when we look at this, we can see that what I was talking about a moment ago. We look at where it hits the x-intercept, okay? The x-intercept. So that's a point where we know it's somewhere along here on the x-intercept. All right, and we notice the x-intercept for the first one is at 0, okay? And then when we did the change, it's going to be at +4. Okay, so what happened is to get from this one down to this one, it went to the right 4. All right, so we can look at the different things they're asking for here. The vertex for the first one, of course, was 0, 0. And the vertex for the second one, after the translation, was at 0, 4. I'm sorry, I'm wrong here. At 4, 0. 4, 0. Okay, the domain again is all real values of x. The range, again, the range is from your minimum up. Your minimums are both sitting here at 0 because your y values are zeros. And so it's going to be y is greater than or equal to 0. And then, of course, the axis of symmetry is going to be whatever the x value is. So it's x is equal to 0 and x is equal to 4. Item number 15. Compare the functions k of x and p of x in items 13 and 14 to the parent function f of x equals x squared. Describe any patterns you notice in the following. Again, in the equations, the change happens prior to the squaring of the function. In other words, we're changing the input value. The graphs are moving left and right. The important thing to notice is that they're moving in the opposite direction of the sign. For example, a positive sign, if I'm adding to the input value, is going to move to the left. If I'm subtracting from the input value, it's going to move to the right. Okay. The vertices are, of course, moving along with the function. They are moving left to right as well. It's like every point in the function will move. The domain and range, the domain is going to be all real values of x for the parabolas. In most cases, the range is going to be changing. Well, no, in this case, it's not changing because we're moving left to right. We're not going up or down. So the range on these are going to be y is greater than or equal to 0. The axis of symmetry, since the vertex moves, the axis of symmetry will move. It'll always be a vertical line that matches the x value of the vertex. So therefore, it'll move either to the right or to the left, depending on what the function does. The changes to the parent function in items 13 and 14 are examples of horizontal translations. Okay, so you're moving along a horizontal. So they're horizontal translations. And again, we've already done horizontal translations, so this should not be anything new to you. Item 16. Item 16 is express regularity and repeated reasoning. how does the value of h in the equation k of x is equal to x plus h squared change the graph of the parent function? And k, that should be f of x equals x squared. And basically it's going to move in the opposite direction of the value of h. So example, if h is a positive value, it's going to move to the left. If h is a negative value, it's going to move to the right. All right, then we have a check your understanding, which I'm going to leave for you to do as homework, as well as the lesson 30-1. And remember, you can always text me or call me for instruction. I can come on Zoom anytime to give you assistance.